The next little section, I just took a portion of chapter 6, and it really focuses on the sex-linked traits and to really differentiate those from the autosomal traits that we've been talking about so far. So our main learning objectives is to look at some different attributes of X-linked dominant and X-linked recessive disorders or traits, just like we did with the autosomal disorders. Differentiate between sex-linked or X-linked inheritance and autosomal inheritance. Look at some examples of both X-linked dominant and X-linked recessive traits or disorders. And then predict the outcomes of X-linked disorders using Punnett squares and also looking at pedigrees to determine the mode of inheritance or transmission. So when we talk about sex-linked traits, and a lot of times they're called X-linked. So sex-linked and X-linked are the same thing. It means they are traits only found on the X chromosome. Okay? And remember, females have 2 X chromosomes, males only have 1. And so that's going to be pretty important when we look at how these traits are transmitted and who is more likely to have these traits. And so one thing about when you're setting up a Punnett square for a sex-linked trait is you have to label, you must label the X's, not the Y, okay? So this is what it would look like if you were labeling, if I said a woman who is homozygous dominant for a trait had a child with a man who was homozygous, or who had the dominant allele as well or something. You can see that we labeled both of the X's on the mom, but we only labeled the X here on the dad, and there's nothing on the Y, okay? So you can't just go and do this like we used to. Then what would you put down here, okay? So you have to set it up where you have the X and the Y, and now you would label the A on this, and then you put the A's on this, and then when you'd fill in your Punnett square, you'd see that the A from the mom came down for the X on the boy. Okay, so boys inherit their X chromosome from their mom. Okay, they get their Y from their dad, whereas girls get 1 X from their dad and 1 X from their mom. Okay, so again, if we look at some criteria, just like we did for the autosomal traits, for an X-linked recessive trait, it's always going to be expressed in the male. Why is that? Remember, males only have 1 X chromosome. So if they inherit that recessive allele, they automatically will have that trait. It's expressed in the female homozygote, rarely in the heterozygote, but usually they have to have 2 of them. So if it's like this, then they will have the trait. Okay? Because remember, this is a recessive, X-linked recessive trait. Affected males will inherit it from either a heterozygote or a homozygote mother. Remember, boys get their X chromosome from their mom. So if the mom was a heterozygote, then they have a 50% chance of getting that recessive allele. If the mom was a homozygote, then they're for sure going to get the recessive allele. The affected female inherits the trait from, she needs to have an affected father, because remember, she gets her X from one of her X's from her dad, so he would already have to be affected, and then the mom either has to be affected or be a heterozygote for her to get that other recessive allele. Some X-linked recessive traits, ichthyosis is one. It's an enzyme deficiency that blocks removal of cholesterol from your skin cells, so it gives the person a very scaly appearance on their legs, very severe. All of us may get a little bit of dry patches on our skin occasionally, but this is much more severe. Colored blindness is an X-linked recessive trait. Hemophilia disorder of blood clotting is also an X-linked recessive trait. Because boys only have one X chromosome, and if they inherit the recessive allele, they automatically get it. These X-linked recessive traits are more frequently found in males than females. Because remember, females with two X chromosomes can be a carrier and not show the trait. Whereas males, if they inherit that recessive allele, they automatically show it. So you'll see a lot more males that are colorblind than females. A lot more males that have hemophilia than females do. Okay? I've had a few students who have been colorblind in class before. They have always been males. This is what a X-linked recessive pedigree may look like. The circles with dots, remember I told you that in some occasions that is what would represent a carrier, okay, or a heterozygote. Okay, remember the other way you could show it is by doing a half shaded in circle. Okay. Why are there no squares with dots? Remember, males cannot be carriers. Okay? No male carriers unless they're delivering your mail. Get it? Mail carrier? Okay, anyway, that was your corny joke for the day. But yeah, they either have it or they don't have it. So they'll either be affected or they won't be affected, but they cannot be a carrier. And then the genotypes of everyone, can you figure out what they might be? Well, since they already have carriers filled out, we know that any circles here would have to be homozygous dominant. All the males like this would have to have a dominant allele. Any of them that would have a dot in it for females would have to be heterozygous, because that's indicating a carrier. A male like this that's shaded in would have to have the recessive allele, like that. And then, do we have any females? Notice we don't even have any females that have it. Again, recessive X-linked traits are more common in males than females. Okay, I'm not going to fill out the whole chart, but it kind of gives you an example of the different things that you would label on those. X-linked dominant inheritance. It's expressed in females with one copy. Remember, you only need one copy of a dominant allele for it to show. Okay? Males, remember, they only have one X chromosome, so if they get that on there, not only do they get it, but it tends to be much more severe in males. Okay? There tends to be high rates of miscarriage due to early lethality in males. So even oftentimes, if males were to inherit a X-linked dominant inheritance while the baby's still inside the mom, sometimes the mom will have a miscarriage because it's just so much more severe on males. And then this is passed from a male to all daughters, but not to any sons. Why is that? Remember, dads pass on their X chromosome to their daughters. They pass on their Y to their sons. So males cannot pass on an X-linked trait to sons. That's when earlier in autosomal, we said there's male-to-male transmission. Well, in X-linked traits, there's no male-to-male transmission. Dads can't pass on the trait to their sons. They can pass it on to their daughters, however. Incontinentia pigmenti, which is a skin disorder, is one of the X-linked dominant traits. Maybe you've heard of werewolf syndrome or werewolf boy syndrome. That's actually congenital generalized hypertrichosis. That is also an X-linked dominant trait. Okay? And you notice here, a female had it, passed it on to her son, and then the dad here, since he's the one that had it, he passed it on to every single daughter they had, because he has the X chromosome that he passes on that had the affected allele on it, and he passed that on to all of his daughters. All right? Let's see if you can figure these out. Can you determine the genotypes of the individuals? Okay? So we know that she's affected, so she needs to have at least one. Usually they're heterozygotes. And then he would not. So you'd have a little one here. That's the normal now, is to have a little allele. This one, because they are affected, he'd have a dominant allele. This one is not affected, so a little allele. Not affected. Is there male to male transmission? Did dads pass it on to sons? You can see, here's the dad. Nope, only passed it on to daughters, because the only thing he can pass on is his X to his daughters. He can't pass on his X to his sons. And the mom, she passed on her X to her sons, and they all inherited the recessive allele. Therefore, they're safe. Okay? So again, a little bit different. You're kind of keeping the same kind of ideas in terms of looking for genotypes, phenotypes, and inheritance patterns, but it's only on the X. So you have to really remember now the difference with males and females and the number of X chromosomes they have.